A power plant is an industrial facility that generates electricity from primary energy. Most power plants use one or more generators that convert mechanical energy into electrical energy in order to supply power to the electrical grid for society's electrical needs. The exception is solar power plants, which use photovoltaic cells, instead of a turbine, to generate this electricity. The type of primary fuel or primary energy flow that provides a power plant its primary energy varies. The most common fuels are coal, natural gas, and uranium, nuclear power. A substantially used primary energy flow for electricity generation is hydroelectricity, water. Other flows that are used to generate electricity include wind, solar, geothermal and tidal. Different countries get their electricity from different types of power plants. Turbine-driven generators. Most of US and world electricity generation is from electric power plants that use a turbine to drive electricity generators. In a turbine generator, a moving fluid, water, steam, combustion gases, or air pushes a series of blades mounted on a rotor shaft. The force of the fluid on the blades spins/rotates the rotor shaft of a generator. The generator, in turn, converts the mechanical, kinetic, energy of the rotor to electrical energy. Different types of turbines include steam turbines, combustion, gas, turbines, hydroelectric turbines, and wind turbines. Steam turbines are used to generate the majority of the world's electricity, and they accounted for about 48% of US electricity generation. Most steam turbines have a boiler in which a fuel is burned to produce hot water and steam in a heat exchanger, and the steam powers a turbine that drives a generator. Nuclear power reactors use nuclear fuel rods to produce steam. Solar thermal power plants use solar energy to produce steam. Have steam turbines powered by nuclear energy, coal, and natural gas. Combustion gas turbines, which are similar to jet engines, burn gaseous or liquid fuels to produce hot gases to turn the blades in the turbine. Steam and combustion turbines can be operated as standalone generators in a single cycle or combined in a sequential combined cycle. Combined cycle systems use combustion gases from one turbine to generate more electricity in another turbine. Most combined cycle systems have separate generators for each turbine. In single-shaft combined cycle systems, both turbines may drive a single generator. Combined heat and power, CHP, plants, which may be referred to as cogenerators, use the heat that is not directly converted to electricity in a steam turbine, combustion turbine, or an internal combustion engine generator for industrial process heat or for space and water heating. Most of the largest CHP plants in the United States are at industrial facilities such as pulp and paper mills, but they are also used at many colleges, universities, and government facilities. CHP and combined cycle power plants are the most efficient ways to convert a single fuel into useful energy. Hydroelectric turbines use the force of moving water to spin turbine blades to power a generator. Most hydroelectric power plants use water stored in a reservoir or diverted from a river or stream. Pump storage hydropower plants use the same types of hydro turbines that conventional hydropower plants use, but they are considered electricity storage systems. Other types of hydroelectric turbines called hydrokinetic turbines are used in tidal power and wave power systems. Learn more about different types of hydroelectric turbines. Wind turbines use the power in wind to move the blades of a rotor to power a generator. There are two general types of wind turbines. Geothermal power plants use geothermal resources to drive electrical generators. Ocean thermal energy conversion, OTEC, systems use a temperature difference between ocean water at different depths to power a turbine to produce electricity. There is a demonstration OTEC system in Hawaii. Other types of generators. There are many different types of electricity generators that do not use turbines to generate electricity. The most common in use today are solar photovoltaic (PV) systems and internal combustion engines. Solar photovoltaic cells convert sunlight directly into electricity. They are used to power devices as small as wristwatches and can be connected together in panels that are connected together in arrays to power individual homes or form large power plants. PV power plants are now one of the fastest growing sources of electricity generation around the world. Internal combustion engines, such as diesel engines, are used all around the world for electricity generation, including in many remote villages in Alaska. They are also widely used for mobile power supply at construction sites and for emergency or backup power supply for buildings and power plants. Diesel engine generators can use a variety of fuels including petroleum diesel, biomass-based liquid fuels and biogas, natural gas, and propane. Small internal combustion engine generators fueled with gasoline, natural gas, or propane are commonly used by construction crews and tradespeople and for emergency power supply for homes.